Hello, geometry students. Today we are doing lesson 10-2, which is finding arc measures. So yesterday we introduced some new terms such as a chord and a secant and a tangent and a point of tangency. Today we are going to be adding some different terms, and in this we are going to be adding a central angle. A central angle is the angle that happens when the vertex of the angle is the center of the circle and its radii go out to the edge of the circle. Okay, this is considered your central angle. So, an angle whose vertex is the center of the circle. The arc is considered to be any unbroken part of the circle consisting of 2 points called endpoints and all the points on the circle between them. So when we have this come out, and this come out, we have an endpoint and an endpoint on the circle, and then all of these points in between here form the arc. So we have a central angle and we have the arc. So in here, because the center C is at the center of the circle, we have an arc here that goes from A to D. So how we call that is AD, and sometimes we have this mark above it. That means segment. So what are we going to do if we're talking about an arc? Then we're going to do AD, and we actually put an arc above it. So this is the notation that we use when we talk about an arc. And this is called your central angle in here. And we would have gone on a geometry sketch pad and we would measure this arc from A to D, and we would find out that that mark, this would be 40 degrees, the same as that central angle. Now, if you guys are looking at this here, we've got an endpoint A and it goes through the center to B. So this is the largest chord of a circle. It is called the diameter. And then if we went from A to B, what would that measure be? Well, because a whole circle is 360, we're talking about a semicircle. So we're going to take 360 and divide by 2. So that's going to be 180 degrees. Now, they do not differentiate when they say AB and they're looking for the measure of arc AB. It doesn't matter if you go around the circle this way to B or if you started at A and went this way to B. No matter which way you're talking about it, it's still going to be a semicircle to find that measure. Now, how do we find this angle measure in here? Well, because of AB being 180, we can subtract 40 from that. And so then arc BD is going to be 140 degrees. And then the measure of angle BCD is also 140 degrees because that is your central angle. So the central angle is 140 degrees, and so is that arc from B to D. Now, as I mentioned here, we talked about minor arcs. Minor arcs are going to be less than 180 and they're equal to that central angle. And major arcs are going to be the ones that are greater than 180. So whenever you're using a minor arc, you're going to use 2 letters when you're going to talking about any minor arc. Okay, so to name a major arc, you're going to use 3 letters, and you have to make sure that you go in the direction that you need to go in. So major arcs are going to have 3 letters, minor arcs are going to be 2 letters. So if we look at this figure here, we've got some minor arcs and some major arcs. So we're just going to extend this a little bit and we're going to kind of find most of the angles in here. So if we've got this right angle in here, we know that B goes through A and E. So this chord right here is a diameter. So it's cutting it in half. So if this AD is coming down perpendicular, then we know this side is also going to be 90 degrees. So we can take 90 minus 51 to get the measure of angle BAC. So I think that's going to come out to be 39 degrees. Okay, we know this one's going to be 90 degrees. Now going back to the information that we've used earlier, we've got this and this coming through. So these two angles right here are vertical angles. So we're going to get this to be 39 degrees. And the last thing that we can find in here is this arc from B to F. Because BE is 180, we can take 180 minus 39 to get the measure of that angle in there. So what do we get? 141, I think. So 141 degrees. Now, you don't always have to find everything, but I just wanted to go through so that you guys were finding it. So let's find arc DF. So from D directly to F, D to F, you cannot go the long way around because the long way around would be more than 180 degrees. So that would be a major arc, and they would have had to use 3 letters to name it. So they want you to go directly from D to F, the shortest distance. So we are going to do 90 plus 39 to find out what that angle measure is there. Okay, now DEB. Starting at D, going through E, because they're telling you D to E to BE, D to E all the way up to B. So now this whole thing. So we're going to have to do 90 plus, and you could do 39 and 141, but we already know that that had better be 180 degrees. So we're going to get that to be 270 degrees. Okay? All right. So we've got some adjacent arcs here, RS and ST. RS and ST share the endpoint S. Okay, so these are considered to be adjacent arcs, arcs of the same circle that intersect at exactly one point. Now, we're going to come up to this and we're going to have another screen in a little bit that's going to talk. And we have had segment addition where we take something like A and put a B on it and then C. So way back in chapter 1, I think it was, AB plus BC equals the whole thing AC. Well, we're going to be doing that same things with these arcs. So we can take this red arc, RS, and add it to arc ST, and that is going to give us the whole arc from R to T. So instead of it being angle addition, it's going to be arc addition. Okay, so we have one circle. They're both at the same center, and they're both X degrees. So we are going to say that arc ST is going to be congruent to arc UV because they are coming from congruent circles or from in the same circle. So two arcs in congruent circles. So we only have one circle, but they're both the same that have the same measure. So I could make another circle and tell you the two circles are congruent, and then their arcs could be congruent also. Okay, so arc addition postula is the one we just talked about. So they went bigger than 180 degrees in here. So you can see AB plus BC. Now, because they're bigger than 180, you can see in here that they had to use 3 letters to name this because it is a major arc because it is bigger than 180 degrees. Okay, but it's still just called arc addition postulate like I showed you earlier. All right, some other theorems that we have to go through. So in here, we've got a radius AC and a radius DB, and they are marked congruent. Therefore, circle A is congruent to circle B. Now I can tell you A and B are congruent circles, and then you can also assume that those radii must be congruent. So this is a forward and back. It's an if and only if. So you can see in here that we've got if and only if. So it's true forward and back. All right, congruent central angle. So we're in one circle. And we have one circle. We already talked about this once. If we have congruent central angles, then these arcs are going to be congruent. So arc BC is congruent to arc DE if those angles are congruent. And it's true also the other way. If these angles are congruent, then it means the arcs have to be congruent. So this is also an if and only if, way back from chapter 2. All right, similar circles. All circles are similar. So whether we have a little circle or a big circle or a gigantic circle, those are not congruent, but all circles are similar. All circles are similar. All right, that should be everything from today. The big thing from today that you're going to go through is if you have the center. Okay, and we have a minor arc. Minor arc is named with 2 letters. So this would be arc AB is equal to that central angle. That is the big thing from today. The central angle is equal to this. So if this is 50 degrees, then we know arc AB is also 50 degrees. Now if I continue this on and just put, let's just say C here, and I put D over here. There's a difference between saying AD and going from A to B to D. Whenever you have 2 letters, you absolutely positively must go the shortest distance, so that we would be talking about a minor arc if we're talking about 2 letters. Then ABD. So ABD is 3 letters. So we're going from A through B and ending up at D. Okay, this is a major arc and you need to use 3 letters to name it. All right, your homework for today will be on line 10-2.